Continuing our look at Polymarket's temperature markets, today we'll analyze a case where, despite signs of heat, the market remains in a calm, comfortable range. The key idea is the same as always. The weather app on your phone is an averaged forecast for a general audience, not a working tool for a precise threshold. The market doesn't ask us whether it will be hot or not. It asks specifically what exact maximum temperature range will be recorded on a specific day at a specific station. And sometimes the most interesting analysis is explaining why an obviously hot scenario doesn't actually turn out that way. Also, I'd like to remind you about our Telegram channel. We analyze more events like this there, and you'll also find more other categories there. And there is some insider information on certain events. Our mechanics remain the same. The market closes based on a specific range at a specific station. For Seattle, it's the C airport. Here we have Seattle. Here is the Seattle-Tacoma airport. Here, we select the temperature layer, place a point here, and then measure from there. Not from somewhere over here, or over here, or over here. Yes, it's all Seattle, but specifically on Polymarket, it's measured by the airport. The source of resolution is the contract. The rules determine the result, not the feeling of walking around the city, right? As for the market entry time, the logic doesn't change either. A 1-week forecast is too rough, but on a 3 to 4 day horizon, weather models provide accuracy within 1 or 2 degrees. It is precisely on this horizon that one should look for the discrepancy between what the general synoptic picture suggests. For example, they say there is a stable anticyclone over the region, which means it will be hot, and what the calculation will actually show, taking into account additional factors that the general picture does not consider. The 3 tools remain the same, as you might have noticed. This is windy, the first one, it doesn't change for us. Also for Seattle, one additional data layer will be added besides temperature. On windy, we can look at the temperature layer as well as the hourly scale. This all shows us the warming dynamics. And this separate layer, so to speak, of aerosols and smoke is especially important for the Pacific Northwest. As we can see, yes, what kind of cloud cover we have, and because of this, some part might not be warming up. Here, for example, it's 55, and here there isn't that kind of cloud cover, it's 61 here. Obviously, everything is perfectly clear and logical. The USA. Since this is the USA, since this is a state, the second tool is wsr.gov. Yes. The states are shown here in the same way. We can analyze a specific station, for example, SAD, which we need. There is an hourly forecast here. Very convenient. That is, you go in, select and scroll through the specific time or range you need, or by the peak. You can also mark the peak here, and it shows you the temperature. Maximum temperature, minimum temperature, everything is here as well. The third tool is AccuWeather, also as an additional tool for our analysis, and WSR API. This is where historical archival temperature data is stored for the same US cities or other countries. Everything is here. Model comparison here is the main thing, the main tool that we always rely on. So yes, we see here the American model shows us 62 degrees Fahrenheit. The European model, however, shows 61 degrees. But at the same time, we can state that they agree on this because the difference is small. Let's break it down with a specific example. So let's say we went to Polymarket and opened the weather section. The market is currently asking us to determine if the highest temperature in Seattle on, let's say, August 14th will be exactly 78 or perhaps 79 degrees Fahrenheit. We are carefully analyzing the data to see which of these two specific outcomes is more likely. The price for us, for example, is 86 on no. At first glance, the market looks undervalued. We've had a persistent high pressure ridge over the region for the second week now, and synoptic logic suggests that with such an anticyclone, the temperature should easily exceed 85 degrees Fahrenheit. That is exactly how most likely part of the crowd that is betting on a higher range is reasoning. What are we doing? Windy. We need the aerosol layer over the Pacific Northwest. That is, how we need to understand how much the ground is warming up, whether anything is preventing any of these points from warming up. We can also go through, turn on the time, and see when the peak will be and what the peak temperature will be for Seattle, whether it will cover our station where we are taking measurements. Yes, and we can see how much the temperature is rising, heating up. Where it's cloudy, the temperature is always lower because the sun cannot heat it up as much as it obviously does without any obstacles. Step 2. This is where we look at our point. Here, right? We also run it through. We look for any cyclones. This is any cold temperature coming here and so on. That is, we see, yes, why we are taking measurements not for Seattle as a whole, because hypothetically, here it is 81 and here it is 77, even though it's all Seattle. So that's why it's always worth paying attention to the station, finding it, and measuring only by it. Not somewhere nearby, not somewhere at the other end of the city, only by it. We also compare two models. If the models agree, it gives us a strong, very good sign that we are moving in the right direction and continuing our analysis. Then we go to WXR-Govage. We also look at the temperatures to see what it shows. If everything gradually aligns for us, AccuWeather and WXRP, we can also look at the historical temperature for all the months in general and draw some kind of conclusion. The same fundamental points as always, as I always explain. Check which specific time of day the range is tied to. The daily maximum is not recorded at noon, but usually a few hours later. Check the station. Yes, I already said that. That is, for Seattle, it's Cassia. It is located south, as we can notice, of the center of Seattle itself, and its readings may differ. And as we have already noticed, they differ from the temperature in the city itself. And at a point specific to this region and season, always check the layer of smoke and so-called aerosols separately from the temperature layer. In the Pacific Northwest at the end of summer, it is precisely wildfire smoke and not cloud cover in the usual sense that most often turns out to be the hidden factor that breaks an obvious forecast based on a single weather model. That is, our weather model might show, well, say an app on your phone 80 degrees, but in reality it's 85, 86, or even higher or lower conversely. So you always need to check. And to summarize systematically, the gap between the market price and the actual probability in temperature markets almost always arises for the same reason. The market often evaluates only one noticeable factor, although the final temperature is the result of several independent atmospheric processes occurring simultaneously. An anticyclone by itself does not guarantee heat if there is a stable layer of smoke or aerosols on top of it that weakens the warming. And conversely, a weak anticyclone under a clear sky sometimes produces a higher temperature than the crowd expects. Weather models are informative precisely because they allow for checking agreement across several parameters at once, rather than just the single most noticeable one. Therefore, the working methodology remains the same. Do not try to predict the weather intuitively based on a single factor, but rather measure the degree of agreement among independent models across all significant parameters simultaneously and translate this agreement into a probability estimate, which is then compared with the market price. Subscribe to analyze more cases like this. Also subscribe to our Telegram channel where we analyze more events. Bye everyone. Leave comments, share your analysis and your successful cases.